Hello PLP Geometry. Welcome to video 12. Now I'm going to break this number 12 up into two videos, but these are the last two videos of Unit 1. So congratulations, we made it to the end of Unit 1 of this brand new learning style. So hopefully your upcoming test goes kind of good. All right, so this is Unit 1, Intro to Geometry. So we're going to call this number 12A. And again, just like we did proofs last video, we're going to do more proofs, but this time we're going to do geometric proofs. Geometric proofs. Okay, so before we get into some serious proof writing, and again, your assignment will be on paper and pencil, again, what I want to do is I want to introduce you to two properties that you might use. So in the last video, we talked about like distributive property, subtraction property. Those things might be used because, again, you might need to like subtract angles from both sides or whatever. But here, there's two more properties I want to show you. So some properties. And again, I'm going to use them as examples. I'm going to show examples that you'll use in the proofs that we're going to do. So the first one is called substitution. So I'm pretty sure you know what it means to substitute, right? So for the substitution property, here's an example, right? So say, or if, the measure of angle x equals the measure of angle y. So if those two angles equal each other, and we have an equation somewhere, the measure of angle x plus the measure of angle z equals 180. So say we know those two things are true, right? Say we were given those two things. Then you could combine them in this way because angle x is equal to angle y, and angle x is used in this equation. We can remove angle x in the equation and replace it with what it's equal to, and it's equal to angle y. So we could then say, then the measure of angle y plus the measure of angle z is 180. So again, what we did, and I'll change colors to show you, what we did is we decided to take out x. So we took out x, and I put the y in its place. That's called substitution. The second property you might use today is called the transitive property. Transitive property. When you hear the word transitive, I want you to think of transition. Okay? So here's what the transitive property says. And again, I'm going to use it in terms of what you might see in a proof. If angle A is congruent to angle B, and angle B is congruent to angle C. So these things we know to be true. Well, if we put them together, if you notice that B is the common angle, I like to call B the transition object. Because A is congruent to B and C is congruent to B, then that's going to force A and C to be congruent to each other. Then angle A will be congruent to angle C. So if you think about this again in terms of transitioning, right, that B is the transitioner. It's the middleman. So it goes away, and you're able to connect A and C to each other. So again, be aware of these situations that you might see in proofs. Okay, so let's do the first proof of your entire geometry career. We're going to prove, so this is a proof. We're going to prove the vertical angles theorem, which we talked about in video 9, I believe, that vertical angles are congruent. That's what we're going to prove. We're going to prove that vertical angles are congruent through this example. All right? So, given. We're going to be given that angle 1, and angle 2 are vertical angles. And again, I like to use shorthand, okay? So vert angles. Here is our picture. Hopefully you remember that vertical angles are created by intersecting lines. I'll put 1 and 2 here, and then notice I'm also putting angle 3. When we set you up for proofs, we typically only give you the things you need to use. So in this proof, you need to think about using angle 3 as well. Okay? And we would like to prove that angle 1 is congruent to angle 2. Okay, so let's set up our 2 columns. So I make it about as wide as the setup is. So here's my statements. You could just put a capital S up there. I'll write the word statements, but if you know by now, statements. And then here's the reasons. Okay, we know we always start with the given. So number 1, angle 1, and I'll use like an and symbol, and angle 2 are vertical angles. And that was given to me. Okay, so in this proof, that really tells us nothing. Yes, you should believe that vertical angles are congruent, but we cannot go directly to that. We have to arrive at that some other way. You cannot use, so if you're trying to prove that vertical angles are congruent, you don't use it in your proof. So keep that in mind, right? We don't use that. So now, as I mentioned, let's talk about how we can bring angle 3 into the proof. Well, if you look at angle 1 and angle 3 and angle 3 form a linear pair. They together make this line. We should know from our video that linear pairs are supplementary. We should know that the measure of angle 1 plus the measure of angle 3 is 180. And again, this is because linear pairs are supplementary. Again, I'm starting to get sloppy. I apologize. Let me fix that word are, right? When you get to these proofs and a lot of writing, I like to go fast. I apologize. Are, there we go, supplementary. Okay? Now, what we've done is we've introduced angle 1 into the proof. That's great, right? What about angle 3 and angle 2? Do they share a relationship? Well, they do. It's the exact same relationship. 2 and 3 are also a linear pair. They are going to be supplementary. Because it's the exact same idea, I'm going to put it also in statement 2. No need to make a new statement. It's the same reason. So I'll put that angle, the measure of angle 2, plus the measure of angle 3 is 180. And again, that's because linear pairs are supplementary. Okay, so we're here, right? We have this information. Hopefully you could have saw that picture and said, yeah, that makes sense. Now, next thing, all right? If I take a look at these 2 equations, they have a lot of stuff in common. Both have the measure of angle 3. Both have 180. Okay? I'm going to focus on this 180. Notice that both of them are equal to 180. If you remember one of the new properties we talked about, the transitive property, right? If this sum is equal to 180 and this sum is equal to 180, then these 2 sums are equal to each other. We're going to use 180 as the transition guy. So we're going to create this equation. And what's nice about this equation is it's going to bring angle 1 and angle 2 into the same equation because right now they're separate. The measure of angle 1 plus the measure of angle 3, that first sum, equals the measure of angle 2 plus the measure of angle 3. And again, this was because they both equaled 180. This is called the transitive property. Transitive property. So what we've done is we've gotten angle 1 and angle 2 into the same equation. So we're getting closer to saying that they're congruent. In order to say that they're congruent, we need to eventually say that the measures of angle 1 and angle 2 are equal. Well, look here. On this side, I have the measure of angle 1 and angle 3. On the right side, I have the measure of angle 2 and angle 3. Notice angle 3. If I were to, and I'll do it really small, if I were to subtract the measure of angle 3 on both sides, they would cancel. And we were left with what statement 4 is going to be. The measure of angle 1 equals the measure of angle 2. The 3's go away. What did we do on both sides? We just did some subtraction. This is called the subtraction property. And again, it's of equality, but I'm not going to split hairs. So now what we just did was we got angle 1's measure to be equal to angle 2's measure. That is almost what you want to prove. All right? We want to prove that they're congruent. Well, you should know from, this is like video 3, number 3, that if two angles have the same measure, then they are congruent. I'm going to slide this in just because I want to avoid my toolbar here. So my last step, step 5, I can now say that angle 1 is congruent to angle 2. And the reason is because angles with equal measures are congruent. And we have proven why vertical angles are congruent. All right. So again, this might be a little bit over your head. And if it is, I apologize. From here, the one thing I want you to focus on is the use of the distributive property in step 2. That's a big deal. And also the idea of using linear pairs. So if you kind of gain those two things from this proof, that's great. And what is hopefully true with you in proofs is that as you keep doing more proofs, you learn the strategy and you get better at doing them. Okay? That's the goal, right? Don't have to be an expert overnight, but eventually get better each and every day. Okay? So that is the first video for number 12. The second one is coming up here shortly.